Hey, good evening. The time is 5:30. Today is Saturday, December 1st. Today I want to try. I want to face another challenge. This time around is operation research. Operation research. I want to test some of the possible questions, like the sample questions in the PDF. That is the handouts. This type of questions, the maximization or minimization. Like I consider it to be of like two parts. You do all the dirty work reading this, and then coming out with this structure to know your objective, the objective function, knowing your constraints, and then the non-negativity conditions. If you take this one, for example, this is the whole question. You have to read, get your variables, decision variables, and then finally be able to state your objective function, to state your constraints. You take it to an example. The objective function is this way, this is the constraint, and then and these are the non-negativity rules. Yeah. So going to give a try, and reading, getting these ones is it's kind of manual. You have to do it yourself. No computer will do it for you. Now, after getting this down, if your variables are 2, like z is equal to x1 plus x2, or z is equal to 2x1 plus whatever, like just 2 variables, then you can use the graphical method. If you solve it, you rule your equation lines, and then where they meet, you form your feasible region, and then each point of the feasible region, you plug it back into the objective function to see which one gives the maximum value, or if it's minimization, which one gives the minimum value. So that is it. If you have 2 variables, then you can use the graphical method. If it's more than 2, then you have that nonsense, the simplest method, or you have to go through that I never understood. Now, alternatively, you can use a software to solve it. So I'm coming to use software to solve this. Oh, this looks too many. You might have to type a lot. Okay, this has 3. Oh, it will be anymore. They are all plenty. I just want some simple one, so that we can use at least that one for, as we the beginners. We know how that too much. This is labor and materials. Hey, no big deal, let's face it. So the variables are many, but it's straightforward. If I'm able to get this down, then there is no big nothing behind. So let's see, someone has done the dirty work, gotten this. It's more than one variable, like x1, x2, x3, x4, s5. up to x7. So what it means is we can use the graphical method to solve it. Graphical method only takes two variables because you plot x and then y. So x is here and then y is here. You can only have two variables, so you can't have more than two. And the simplest method, I don't know what it is. So I try to go around the software. Of course, I'm not sure any other software for you to do, but it's good if you get your hands dirty on things like that. So first of all, I had to find a way to get the software to solve it, and then I kind of came out with I found two in my search for this question related software. The master made mention of Ample, and I also found Gams. Like, they are all softwares to help you solve questions of this nature. Now I found both, but I stick to the master's one to use the Ample. And it's so complicated, their things. Ample. It's not for free, it's for sale, and that is where the interesting part is. So after about 3 weeks of serious searching for this software, I finally got it. And the more I tried searching for it, the more clearer I became of what the whole Lampo shit is about. Like, in short, it's not Ample that is actually coming to solve the questions for you. This one is not Ample. Ample is a software. It's kind of like an ID. It's an environment that allows you to type your questions and other things. If, let's say, in other language you say you can do and then do your, like, check your syntax errors and those things, but the actual compilation or workings is done by another tool called Solver. And so you can have the Ample, I can have the Ample, but behind the scenes, let's say, what compiler are you using? You say you are using, let's say, a Blood Shell. I'm also using whichever compiler. So Ample also has solvers. Those are the ones that solve the questions for you. And I found there are so many of them. They're definitely not for free. There is a Cplex solver, there is a minus solver, there is IPOPT solver, there is which one again, etc. Let's move on. And each one and each stream, like the kind of questions it can solve, the kind of questions it cannot. So if you using the Ample, you try this one, it couldn't give you the right question answer, or like whatever reason, you can switch to another solver. And one thing I also realized is the solver, their default settings. So for example, some of the solver just give the objective function, like the optimal solution. Like, it will just get the variables, put this one and tell you the answer is this. Others will give so many details that I don't even know what it's about. So I realized that differences too. So now, assuming you've gone through the struggle like I went through, you finally gotten your Ample software, you have it on your computer, it's working fine now. Now let's start coding. So first of all, you open it. And I can open it from here, Ample, and that is it. Let's see if I can kind of maximize, increase the font a bit. So I have it this way. This is the Ample that. Yeah, this is it. But what I did is actually kind of write the code in Notepad. your questions, then use the ample to solve it. Like that is the idea I'm using. Like if you are compiling Java, you can be doing it in whatever text editor you save it, then you run it from the command. So basically that is the whole idea. So if let's minimize this first and get our questions written down first. So if I push this one to the right and I push this one here, so this is it. Now hey Tani, now I'm from Kaunu. Hey, let's go. I did one when me face challenge kakra. Like a software software. I am a person meeting being from run, like from the command line. Yeah, inti me the environment variables no. Now, Tizen Fan say on the computer no. Over code drive D. Now, me more example where is located on the computer. Oko drive D maybe wako that software no. Nanka what be command prompt or nanka ude yeni ope. But unse be command prompt no ho na. Now person will next folder a slash then the name of the folder. Say emuna will be so slash the name of the folder. So now I may be no command prompt no. I find getting that directory. Me finding it difficult to navigate to get the full directory of where my files are. So like this is a folder like in which directory and as application be say be or command no like even say be command line by default in which folder is it operating from. To say me but on say no application no ha e be my code drive C na my code application no. In the environment say me launch application na the person me call a folder next to where I am now and baby I have say my go be directly in the application. I have application no even from command prompt I had me person me be another folder. I just have to type slash then the name of the folder. So and also me navigate and I'm close our folder no. So me next folder I just have to type slash then the name of the folder. Now me go can environment variables no. So me begin from the command line. Then me bought slash the name of the folder. It doesn't work. You say me type full directory no. From drive C. I will drive D slash then a folder. It's like I okay, in fact I have folder non call system 32. Windows system 32. Okay. Let's continue. I was trying to do some trick. For example, here, okay, we'll get to that place. So let's see. It's just a way to make it easy to open the ample from different places. That's what I was trying to do. So here, so the variables, we have x1 to x7, and they are all greater than 0. So just like in normal coding, you declare them. So we have and this is the word to use. So x1 is greater than is equal to 0, and you terminate a statement with semicolon. So we have try to do this. We have this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. So we declare all our variables, and then the condition is what is this? ZG is less than 40, so they are all for OG. Now let's attack test. So we are to the week. This is minimize. So we are minimizing, and the keyword to use is minimize. You can't use anything else, so we have to type minimize. Then your objective function, you have to give it a name. So let me say mini, and then this is it, and then you write your objective function, which is x1 that's x1 plus x2 plus x3 plus x4 plus x5 plus x6 plus x7. Remember, a statement is ended with semicolon, so that's the minimum. Then the constraint, the keyword is subject to. Now let's say constraint 1. You have to give the constraint a name. So then we have x1 plus x4 plus x5 plus x6 plus x6 plus x7 is greater than or is equal to 35. Then another subject, another constraint. Every constraint you write subject to, then you give a name. Subject to, you give a name. So subject to, let's say constraint 2. Then you have x2 plus x5 plus x6 plus x7 plus x1, which is greater than or equal to 55. And then a subject, okay, let's go subject to constraint 3. So then we have x3 plus x6 plus x7 plus x1 plus x3, which is greater than or equal to 60. And then subject to, and then constraint 4, we have that is 1 2 3 4. So we have x4 plus x7 plus x7 plus x1 plus x2 plus x3. So that one to greater than or is equal to 50. So then we have subject to constraint 5. That column is a must. That's the syntax. You have to bring it. So we have x5. What have I done? So we have x5 plus x1 plus x2 plus x3 plus x4 greater than or is equal to 60. And we have subject to constraint 6. So 1 2 3 4 5 6. So then that one too is x6 plus x2 3 4 5 x2 plus x3 plus x4 plus x5, which is greater than or is equal to 50. You terminate it. Then you have a subject to constraint 7. So we have x7 plus x3 plus x4 plus x5 plus x6, which is greater than or is equal to 45. Go to 45. Less than or is equal to 40. So that is it for our constraints. You have to type them this way. Minimize, you have to write the correct one, minimize, and this is how you declare variables for this. And then so if it's up to 100 200 constraints, you have to type all of them this way. You have to type all of them this way. Now then you save it. You save it into the ample folder. I have it here, modules. This is why I have it. Whatever name you want to give it to, let me say doctor dot. Don't forget the extension is mod. So that is the extension. So we have it that way. Now let's pull and pull. Which of them there too? So let's pull and pull. And first of all, we have to move. We have to go and pick that folder and then that file and then work on it. And to pick it, this is how you do it. Module, then the directory, which is I think E the backslash is in ample slash from ample. Which folder again are we going? I think it's module before the name of the file, doctors.mod. Remember, we terminated with semicolon, so it can't find it. So that means I've typed it wrongly. So we have it this way here. Let it write E and pull. So, and the modules. This is the path. I can erase this. So typing module. I'll paste this, then backslash. The name of the folder is doctor. Okay, why is it? Because I wrote doctors. Let's try that one. So let's see. So this is the first one. No, it's not because of that. Modules. Next, so let me come here again. Let me have it this way. Then doctor.mod. Syntax error. Okay, it's module, no modules. It's module, and then it's already defined. Yeah, x1 is already defined. So let's kind of reset it, and then we try again. Syntax error. Okay, we're saying syntax error. That makes sense. Syntax error. Subject to. Subject to con1 to s1 plus x2 plus s3 plus s4 plus x6 minus x7, which is greater than or equal to 35. Saying there's something on this line, it's problem there. Then the constraint 1. So x1 plus x2 plus x3. I didn't mean my objective. Let's see. Reset. Minimize objective. Minimize. How is the spelling of minimize? Yes. So is it this? Reset it. Reset means like just you save as, or like you reload. Then put it that way. Reload. Yes, sir. I'm busy. What is computer engineering? So we have but it's saying syntax error, meaning it's able to detect the file, just that it make some errors in it. So let's look at it. Well, x1, x2, x3, x4, x5, x6 plus x. Let me test some of the previous mod. Let me see, show. So variables. These are the variables. Objective is this one. So variables, these are the objectives. You see the structure of what I've made something. Okay, let's see. A couple of them. So let's see this. Maximize. Nice. It. Subject to this. There's no problem with it. A minute. I hear someone making noise. I have to check. So this is the more, let me see, syntax error. I think it should be Z. The software definitely was done by Americans, so minimize the spelling should be minimized. Small letters. So if you come here, then you kind of reset it, like reload subject. Let me see. I think it's supposed to be small letters. Small letters. And then you save, and then you kind of reload. Con 1 is already defined. Subject to validate meaning. Doesn't the reset didn't work? Con 1 is already defined. So con 1, okay, so here will be con 2, 3, 4, 5, 1, 2, 3. Yeah, like these two constraints can have the same word. That makes sense. So then you reset again. That test, boom, it works. So now we fix all the errors. We type them here and then we fix the errors. So what is next is to call which solver you want to use. Like which, if it's, let's say in C++, which compiler do you want to use? So which solver do you want to use? So there is Cplex, there is I think minus, and they are all in the folder, so you can get used to. These are them. This one is a solver. Snop is a solver, minus, local, dov. Then when this, have not been able to use this. Cplex, IP solver. These are all solvers, so you can use any of them to do it. And then this is, you choose solver, saying option solver, then you specify which solver you want to use. So let's say you want to use Cplex, and then you just say solve. That's all. It's done. So the objective function is the objectives the maximum. The solution is 75. That's all. You've solved it. That is all. We are done. And if you want to use different solver, so you just go back and say option solver, and then so you want to use the minus, so you say minus comma. Okay, you pick that one, so you add the solve, and that's all. That one is giving the optimal solution. So these are no, the first one to set optimal solution. So let's see. Solver, and then go PT. If you solve this one, boom. This is the one I earlier said. Sometimes aside the objective function you get, some of the solvers add complex so many things into it that I don't know what it means actually. So there is so many things. It's not that clear. So what we can do is to instead of displaying it here, we can display it into a file. So I think it's the same thing. Solve So then this arrow, then the name of the file. So let's say t dot mod or whatever name, syntax error. So whatever name dot let's say log. So whatever name dot log. Oh, I have to pick the full path. This is the problem I was having with this is like why I call that Tony. How he can help me go around this. Because one thing is, if you open the solver, right, like the ample inside the folder direct, things are a bit easy. Option solver, let's say minus, and then we say solve. No variable here, so let's pick this one first. Module slash doctor.mode syntax error modules. Yeah, this one is module. So then we say solve. So it's also, we can say the solve should rather go to test.log. Yeah, so we can come here into that folder and then to the module, and then you can find test here. Yeah, that is it here, test.log. So it's not creating it. Let me see. Let's see there what we have first. So we can say display x1, x2, x3, x4, x5, x6. Okay, so these are the actual variables of, let's say after solving, this is that x1, x2, x3, and the rest. So we can see all this one and then to test.log. Let's see that test.log has something now. Okay, so it works now. You can output your result instead of showing it to the user to a file like this. So let's see there. So I think the IPOPT, this solver is the one that so you see the display ID, and then we can no, it's not this one. We want the actual solving to be here. Now solve. Now there's arrow test.log. See, the result is not coming, but anyway, that is it. If you do that test around, you'll be able to see how you can or is it a minus option? So minus, and then it says solve the question. No, this one just gives the optimal solution. So let's see some other solvers in it. There is minor, the local LOQO. So you just say local semicolon and then say solve. So I want to solve. So this is the objective function, and actually that one gave it in decimal. So if you are interested in getting decimal, and which I saw something here, the display, not here. Let's display them here. Like, see, there are those decimal 10.89, 10.9.1. These are human beings, so you can't have 10.0, 10.8. So you can adjust this one a bit as integer, then you make it as integer, so it will kind of do the run up for you. Integer, and then integer, so that is it. And then remember, any changes you do, you have to reset it. If I even type this, so you have to reset this, and then you display this. X is not defined, yeah, because you have to pick it again. Modules, yeah. Doctor.mod, then we say it's solve it this way. Then you can say display x1, x2, x3, x4, x5, x6, and then x7. So it didn't work. I realized which of the solvers. One of them, if you change it to integer, then it will have done that for you. Let's see, option. So simplex solve. I barrier algorithm. I don't know what it is, but I realized if you add the integers, the simplest solver is not able to solve it. Then it comes with this error that no license to use the barrier algorithm. I don't know what it is, so you just have to change the solver to minus. And then that's all. That same question, this one will be able to solve it. But I don't know why it's still showing the negatives. But basically, that is a sample test. Okay, so let's go and see if. Unfortunately, it looks like the book doesn't have an answer. The book doesn't have an answer, but anyone interested can solve it manually and see if it matches. So, okay, let's say this one. Okay, this one has this one is solved. So this is a pretty function. So this one is solved. So let's see this one. We have x1, x2. This is just two variables, so that means you can solve this one using the graphical solution. So, but we are going to use the sample software to solve it. So we have our two variables. First is let me see, x1, which is greater than or equal to 0, and we are doing this because of this non-negativity. That is why all the variables have to be greater than 0. So this is greater than or equal to 0. Then which are we minimizing or maximizing? We are maximizing. So maximize. Then you give the name of your objective function. Let's say I prefer to call it this. Then you say this. That's the center, 15x plus 10. So we have 15 times x1 plus 10 times x2. Remember, every sentence has to be, or statement has to be terminated with semicolon, like C# and C++ and everything. So subject to constraint. So we can say subject to constraint 1. And actually, if you read the question, you can actually know what constraint 1 is about. Something, maybe it can be labor, it can be hours, it can be whatever, but we are just calling it constraint 1. So in that case, people have said subject to let's say hour, or like subject to labor. The name to use here is entirely up to your preference. So let me say constraint 1, and that constraint 1 is 4x plus 6y is 4 times x1 plus 6 times x2. And then we have another subject to constraint 2. So that one too, we have x plus 0. So we have 3 times x1 plus 0 times x2. That will definitely be 0. This one is less than or is equal to 360, and then this one too is less than or is equal to 180. Then we have a subject to constraint 3, and then we have, I'm just giving this space for formatting, like just to display it so that it's clear to see, like the human eye can see it. So this is 0 and then 5, so we have 0 times x1 plus 5 times x2, which is less than or equal to 200, and then that's all. The non-negativity, that's what we've done here when declaring the variable, so they will definitely be bigger than that. And then the next thing is to save it into that folder where your module, we are calling that folder modules, you can call it anything. So let's call this one let's see what's the problem about limited the coordinates of coordinates in the to get a name for it. Okay, no problem. So let's call it no name.mod. So that is it. The first step is done, and then we now go to our code. So we have to load it first, and the loading is you use a module slash no name.mod. Constraint 1 is already declared. What is that? Already declared where? Because let me close and open again. Yes, I've used constraint 1, but that was in another file. So why is it telling me constraint 1 is? And so let it declare. So let's say modules, and then we name it no name.mode, and then yeah, I think it was still holding those variables. So and then that's for meaning there was no error. Solve, and that's it. We are done. Objective function is 110. So let's see. Don't disgrace me, don't disgrace me. Objective function, you put it here. Objectives, this is the optimal solution. Optimal solution. Now I think we are right. This is the optimal solution. We are maximizing it, so the biggest value. This is the objective function. So after putting your coordinates in it and you solve the biggest one, that is the maximization. So that is 110. We are right. So that is it for the objective function. So let's try it and let's solve and see options solver. Which of them? PT, VT, and then we say solve. This one tends to bring a whole lot of other things. Number of objective functions evaluated 7. Number of I don't understand them. Objective functions, blah blah blah. I'm sure this one there is only the master that can understand this nonsense. So the number of equality constraints, the total number of inequality constraints, one inequality constraint with only one lower bound, with only one upper bound, with only what. Well, that's it. You've gotten it. That is the 110. So let's see another example. We are not doing the reading. Let's say it's done, and this time we are minimizing. So go straight here. This is the output. So we can say new, and then there are two variables. So just declare them var x, or you can say x var x, which is less than or is equal to 0, and then var y, which is greater than or is equal to 0, and then minimize. You give it any name. What are we minimizing? Let's say we are minimizing labor, so we can say labor. You don't have to bring the underscore, whichever name you want. So and then you bring this one, and then minus x plus 2 times y. That is what we are minimizing. And then the constraints. So that one to subject to, we have C1. When you say there's minus 1 times x plus 3 times y. Instead of x1, x2, I'm using x and y. So basically y is the x2. So subject to this plus 3 times y, which is less than or is equal to 10. Then you have another subject to C2, that is 1, or we can say x. I don't know if minus x will work here. So minus x, if it doesn't work, we come back and fix our things, right? So we have x plus y, which is less than or is equal to 6. Then you bring your command and subject to C3. The C1, C2, C3 are the constraints. So that one x minus y is less than or is equal to 2. And that's all. And then we give it a name. Let's see. Don't forget the extension. I'm calling it all.mod. I want to be thinking around which name to use. So whichever comes to my mind, I use it. So then you pull your you put that file to that file you just save. You pull it, and to pull it to say module. Module is a keyword. This modules, that's the name of the folder, but this one is a keyword. Module. So if that's this second module. So if this folder was called like MOD, or like MO, we'll have say module MO, and then slash all.mod. J is not defined. That J is not defined. So label J. Let's see our file. J. No, we don't need any J here. So go away. Okay. because we changed the name of the file, it can't find it, so we have to resave to move, and then you save it all to move. Just tell it exist already. Yes, replace it. So we can move slash mode. See, it already exists, so we have to reset it. Forgot to do that. So after making changes in that file, we have to reset it, and then mode.mode. Done. So we solve it, and that's all. Still using that nonsense solver. Let's use the C++. So that one gives clear. This is the optimal solution. I don't know what these guys are saying. That optimal solution is found, but if you go to do so many things, options, solver, C++, and then solve, and then that's all. -2. I'm not sure I'm right this time. Let's see. Yeah, that's it. -2. The minimum probability function is -2. That's okay at the point. It is hence the optimal solution for the given. Optimal solution is -2. That is it. That is it. So that is just so. Should we try this? Oh, we've done this already. Yeah, this is the first one we did. Let's see if we can get another one. Okay, this is the structure. This is the structure. And this, separate this. So that's it. All these ones are 2 variables, so they can solve with the graphical method too. If you're not using the ample software, you can use the graphical method. But if it's more than 2, that's where this nonsense comes in. Simplest tableau. You can pick some French report, and then they will confuse you next week. This thing, what is tableau? So that is it for the ample. There are a lot of things you can do. Actually, it has some kind of concept of the for loop and other things to display data nicely. Let's try and pull some of this. Let's see more, and then we have let's see in that folder the more, and then what is this Egypt 2 is about? Big production. Let's see. Okay, so this has a lot of data, so let's see that one. And then the file name is so we can just come here and then and then we pick that one, and then we solve it, and then the bailing out after 10 warnings. This one is already declared. Article is already declared, so let's reset, and then let's do this one again. So yeah, the optimal solution is this. So if I say show. So these are the variables, like different. So says these are the constraints: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means this has 11 constraints. So let's show the values for all the constraints. We have D, R, EQ, MP, L into LB and DLIM 1 times the power LIM blah blah blah. So and this you see is able to display it nicely. It's kind of in a table form. It's kind of in a table form, and that's the for loop and other thing. It's not for loop exactly, but I think that is how it should work. If you look at the structure, there is from in and other nonsense there. So okay, that's it for ample software. I have it. I found it. So the software from one site like that from torrent. It's unfortunate. I found it from torrent and it took me like 3 weeks. Always it was downloading to download it to stop. But I finally have it on my computer now. Anyone interested can link up and then to just to test and see how those things works. And if you go to the ample site too, there's a student version, but there's a limitation to how many variables you can work with, or like how many constraints you can work with. Another option I found is the narrow server ample, or how is it called? Neo servers. I think these ones are kind of online servers. So like to be able to use it, always have to be online, and then you submit, they will do the calculation. Like remote servers, just like instead of having your servers in this folder here, we're switching in between, you rather submit it to a remote server to solve and then bring you your answers. So that is one alternative too I found. So that is it for the linear inequality constraints of maximizing and then minimizing, solving them using the software. Another one I talk about is the GAMs. I have the documents around it, but I've not read to see how they work yet. At the right time I'll test that one to see how those ones do work. So have a nice day. Hope it's helped in some way.